It is being said that all of life is constantly in motion. Desire keeps us moving. Desire inspires us to be brave, to dream, to create. Desire is our divine connection with the creative force of the universe. Hello, dear students. In this video, we are going to talk about some of key points of Chapter 1 dealing with motion along a straight line. So, let's begin. First of all, you have to know that physics is based on experimental observations and quantitative measurements. Each measurement is associated with a physical quantity such as the length of an object or its velocity. All measured quantities are classified into two measured types: base or fundamental quantities on one hand and derived quantities on the other hand. Physical quantities such as length, mass, and time are called base quantities. Others like velocity, acceleration, force, density, pressure are called derived quantities. The measurement of any of these physical quantities is made relative to a particular standard or unit. The main objective of this chapter is to learn how to describe the motion of an object along a straight line. This motion is described from kinematics point of view, and this means that we want to know how an object is moving regardless of its shape, its mass, as well as the forces applied on it. The object is also considered as a point particle. The motion of an object will be described with the following three physical quantities: its position, xt, which is called instantaneous position; its velocity, vt, which is called instantaneous velocity; and acceleration, at, called instantaneous acceleration. The average velocity of an object is the rate at which this object changes its position from one place to another. Technically speaking, the average velocity is defined by v bar equals delta x over delta t, where delta x is the change in position of the object, of course, which is called displacement, and delta t is the total time taken by the object to change its position from one place to another, called ellipse time. The instantaneous velocity is defined as the rate of change of the object's position for an extremely short period of time, called instant. Technically speaking, the instantaneous velocity is defined by the first derivative of the instantaneous position with respect to time. Vt equals dxt divided by dt. Average acceleration is the rate at which the velocity changes. It is defined by a bar equals delta v over delta t. The instantaneous acceleration is obtained using the same process discussed for instantaneous velocity. Thus, instantaneous acceleration is defined by the derivative of the instantaneous velocity with respect to time, and at equals dvt divided by dt. Let's finish this short video by considering the following example. The main pulmonary artery is a short and wide tube-shaped artery that carries deoxygenated blood from the heart to the lungs. The typical length of the main pulmonary artery for an adult is about 5 centimeters. The speed with which blood flows through the main pulmonary artery is about 60 centimeters per second, which is equivalent to 0.6 meters per second. If you are asked, how long does it take a blood cell to completely pass throughout the entire length of the main pulmonary artery? What will your answer be? I'm sure that you are now able to answer this question, aren't you? Thank you so much for watching this video, and remember, don't let mental blocks control you. Set yourself free, confront your fear, and turn the mental blocks into building blocks.